Okay, today we will discuss the process of implantation. So, and what we're gonna observe now. So, after the fertilization, we have the so what we have in after fertilization. This is the ovum, or so which is not ovum anymore. It's a zygote. Yeah, it's a zygote. It's also named as a totipotential stem cell. So actually, all the cells of human body, all the cells of even placenta, all the cells so which further will become the fetus and even supportive organs of the fetus, they are made up of this cell. So this is the first cell. So with in genetic code, so it will be similar to so future human being. Okay, these cells are polar bodies. They're known as first polar body and second polar body. Sometimes when unexpectedly fertilization of first polar body happens, it opens the third polar body. Hamza, please shut down your microphone and don't switch it on, please. My request. So this is the first polar body, this is the second polar body, and sometimes when fertilization of first polar body happens, so then it leads to formation of third polar body, but it's usually never happen. So and actually they play no role in future, so they are just collectors of excessive genetic material of the ovum. So because in beginning, you remember, in frame of zona pellucida, which is present here, so in frame of zona pellucida we had a diploid cell, diploid cell. But after the meiosis, first meiosis, we have two cells with equal amount of genetic material, and after this we have a second meiosis. After the fertilization, second meiosis performed, and then a second polar body just outpoached the little amount of genetic code. So half of a haploid cell is formed here. So this genetic code, and then it's remained in the frame of the zona pellucida. But they play no role again, so just keep it in mind. Okay, and we have zona pellucida. It's a hardened structure which keeps the size of the embryo till the moment of implantation. Before the implantation, it's remained and removed only due to implantation. And around it's remained the cells which are named as corona radiata cells. Just reminder, so it's the same cells which were responsible for synthesis of progesterone, so which attract sperm cells to the zona pellucida. But nowadays they are inactive, and gradually they will die. They will shed out from the surface and die because they handle their role and they just finished. Okay, and now we'll talk about zygote. Zygote in a frame of zona pellucida are splitting and forming two blastomeres. It's also totipotential cells, and 4 cells, 8 cells, 16 cell stage, and after this we name it as morula. Morula, so keeping the size of the zona pellucida, and actually this process handles along with the fallopian tube, and fallopian tube is very pretty narrow. Narrow space, and through which it has to pass. And also in fallopian tube we have a special cilia, so which assist in the motility of this embryo toward the uterus. So let's keep it in mind. Okay, and again, I repeat it many times, but I will repeat it again and again. So this cell amount of the cells is different, but size of all the cells is similar to the size of the zygote. Okay, then it enters into the uterus cavity. So approximately in 4th, 5th day. So after the 4th, 5th day, so this so we have 32 cell stage, and then division of the cells goes unequal. So some cells are dividing faster, some cells dividing slower, and inside the uterus we have we have a so named uterine milk. So what is uterine milk? It's a mucus which is produced by uterus to feed up the embryo. So and zona pellucida is permeable for this uterine milk. It's a nutrient. Yeah, it's a nutrient for the cells, and with the help of this uterine milk, so the cells can grow. But again, I remind you, so around we have zona pellucida, which restricts the growth of this embryo. And another function of this zona pellucida is prevention of implantation of this embryo, because surface cells which are present here, they're very sticky to the endometrium, and even sticky to the fallopian tube. So that's why the very important role of zona pellucida to keep integrity before it enters into the uterus. But when it enters into the uterus, so uterine milk is accepted by embryo, and it leading to differentiation of the cells into these two cell masses. And this outer part is named as outer cell mass, and this inner part is named as inner cell mass, or another name. It's and this is together is named as blastocyst. Blastocyst. And inside the blastocyst is formed. Sorry, a little back. Inside the blastocyst, we form the blastocyst cavity. So this blastocyst cavity actually which divide in this inner cell mass from outer cell mass, most of outer cell mass. Okay, another names of these structures is this outer cell mass. Another name is a trophoblast, and inner cell mass is known as embryoblast. As name implies, trophoblast is responsible for formation of supporting organs of the embryo, so like placenta, and inner cell mass, it is responsible for formation of embryoblast. Yes, so they're responsible for further embryo formation. So and then our future fetus is this few cells, but this trophoblast is just supporting organs. Okay. And then shedding out of the zona pellucida happens. This process of shedding out is named as a hatching. So that's like egg hatching. Yeah, so that's similar. We just naking this embryo. So it happens due to pressure appeared inside. As well as said, uterine milk is absorbing the pressure increasing from inside, and it in one moment it hatches. But we have pathologies in which zona pellucida is too thick, too tender, and then hatching does not happen, and then it seems like just casually infertility. Yeah, so then female doesn't have, so it doesn't attach to the embryo. Okay, embryo doesn't attach to the uterus. That I meant. Okay, and approximately at day 6, so this embryo attached to endometrial wall, as we discussed in previous lecture. So and so when it attaches, so this trophoblast, outer cell mass, starts to differentiate, and activate some chemicals. So and this, let's discuss it in next lecture, in next video. So here it will be discussed. Again, when trophoblast attaches to endometrial wall, so it starts differentiation process. So and then and this trophoblast differentiates into two cell masses, which are named as cytotrophoblast. So 1 second, which is named as cytotrophoblast, which remain the trophoblastic tissue, but but this cell mass, it will be named as, somehow it will be, it's a cytotrophoblast here again, and this is syncytiotrophoblast. Syncytiotrophoblast. So this difference between the cells is that cytotrophoblast, they keep the same structure as normal cells, so one cell, one nucleus, cell membrane, independent. But in syncytiotrophoblast, as it's shown here, so it has a cytoplasm is common for all of the cells. Nucleuses are different, but cytoplasm is fused. And these syncytial cells, so they are present along with the embryogenesis, along with our adult life even. And most of the syncytial cells, they have one function. It's erosion of surrounding tissue. So they very actively can produce erosive enzymes, and they can penetrate deeper and deeper. Okay. So you see, inside the trophoblast, we shouldn't forget about the embryoblast. Embryoblast here forming two cell layers. It's this layer is named as epiblast, this blue cells layer, and this cell layer is named as hypoblast, epiblast and hypoblast. So don't confuse this with ectoderm and endoderm. It has a lot of correlations, but it's not. And together, this epiblast and hypoblast, they form in the bilaminar embryonic disc. Bilaminar embryonic disc. And also, okay, a little later it will be shown. So this cavity is formed. So yeah, okay, as I said, hypoblast and epiblast. Okay, and also furtherly, so when differentiation goes, and also here you see that inside the syncytial trophoblast form the cavities, so which are responsible for feeding of the baby, and we use the sources of a female body, so to provide the sources. Hamza, please switch off your microphone.
With the pan keeper.
Okay, I have to kick him out. Okay, and that's and now you see, sorry, interrupted. Inside the embryo happen in the process of differentiation, again hypoblast and epiblast, and epiblast forming the amniotic cavity. So there's a few cells which are appeared as a roof of this cell, so they form the amniotic cavity. And below the hypoblast, so entire this cavity formed by trophoblast, it forming the yolk sac. Forming the yolk sac. So it's also known as the exocelomic cavity. So exocelomic membrane and forming the exocelomic cavity. Exocelomic membrane and inside the exocelomic cavity, but together with the hypoblast, they form the structure named as a yolk sac, also named the primitive yolk sac. So because we have a secondary yolk sac, so later it will be discussed. Okay. Around, syncytial trophoblast keeps growing, so and it goes along, so it's not divided into stages. Yeah, so because along with the differentiation of the bilaminar disc, we have a syncytial trophoblast expanding, and this inside the syncytial trophoblast form the lacuna cavities. Yeah, so which syncytial trophoblast eroding the capillaries, and also eroding the glands which are present here, which producing some compounds, and blood fulfills this lacuna, and here they named as a lacunary network. Also, syncytial trophoblast produce some chemicals which causes the dilation of capillaries here, and then more blood supply enters into the syncytial trophoblast. So and then blood filling it. So and now we have a next stage of feeding of the embryo. So now we established the proper nutrition of this, and it's a primordial of the placenta. So then by diffusion process, so through the syncytial trophoblast, these products are absorbed by the embryo and trophoblast. And now you understand the principle of the naming. Yeah, so trophoblast, trophos might be known from Greek. So trophos means feeding. Yeah. So this and now syncytial trophoblasts and cytotrophoblasts are served for feeding of the embryo. Okay, in the next stage, so from this side of the cytotrophoblast form the new cell layer. It's again, it's not inside the embryo, future fetus embryo. So it's a extra embryonic structure, which is known as extra embryonic mesoderm. From this site of cytotrophoblast produced extra embryonic mesoderm. Extra embryonic mesoderm is formed between yolk sac and cytotrophoblast, yeah, and filling all the cavity, and also between amniotic cavity. Yeah, so that's it's like a medial cells between them. So actually they will establish fine capillary network of the yolk sac. Oh, sorry, fine capillary network of the placenta. It's known as extraembryonic mesoderm, yeah, as I said. Then extraembryonic mesoderm actually divides, so during the enlargement of embryo, so some cells getting more attached to the cytotrophoblast, some cells are more attached to the yolk sac and amniotic cavity. So, and we have a parietal extraembryonic mesoderm and visceral extraembryonic mesoderm. And appears the cavity between them, so which is known as a chorionic cavity. Chorionic cavity. So yeah, here it's chorionic cavity. Might be you heard about this. Okay, as well on 13-day embryo keeps growing. So some portion, little portion of the yolk sac outpoached and forming the exocelomic cavity. So, but with the connection with the connection with the extraembryonic mesoderm. And now after this outpoaching, so we forming the secondary yolk sac. Secondary yolk sac. Okay, I remind you, yolk sac is used for feeding, so in birds, yeah. But we don't have egg anymore. So we don't have egg. So we have so we don't need to collect some nutrients here because we have we can align the feeding from the placenta. Yeah. So like here, primordium of the placenta is formed. That's why yolk sac is not necessary to be evolved. So, but still we have evolutionary gain, so to form this yolk sac, and now we can't avoid this usage of this yolk sac in our embryogenesis. But evolutionary nowadays, probably it's useless, and primary function of yolk sac is lost. Okay. And then keeps growing. So yeah, about this exocelomic cavity. So in our body, in our embryogenesis, it just apoptosed. It just dies. Yeah. So and then without any consequence. But in birds, so if you ever broken the egg, you have seen this exocelomic cavity. It's this air-containing cavity, so which keep the egg floating. Yeah. So in water. Okay. And now you see, as a result of the 13 days, first 2 weeks of embryonic development, we have a bilaminar embryonic disc made up of epiblast and hypoblast. Okay, around from the cells of epiblast is formed amniotic cavity. From the cells of hypoblast is formed yolk sac. Between them, between cytotrophoblast and yolk sac and embryo itself, we have a extra embryonic mesoderm. Exocelomic cavity outpoached and formed the secondary yolk sac. And here we have this structure when mesoderm, extra embryonic mesoderm, so parietal part and visceral part of this extra embryonic mesoderm are connected, and this is known as a connecting stalk, future umbilical cord. It's a future umbilical cord. Connecting stalk, future umbilical cord. Okay. And the next video, it's a gastrulation. So in a gastrulation, we'll concentrate our attention only on the bilaminar disc. So what is happening around? So it's just still keeping of expanding of trophoblast and alignment of better blood supply to the embryo. So now we'll concentrate attention only on these two disc layers. It's also fascinating. So yeah, I know that some students when the first time come into the class, so they prepare this lecture, this gastrulation process like it was in school. So like gastrulation, it is so formation of gastric tube or digestive tube. Yeah, so like folding and gastric tube formation. Actually, in placental animals, we are placental animals, humans are. And so we talk about gastrulation only in frame of in frame of formation of 3 germ layers. Again, gastrulation is the formation of 3 germ layers. You know them, most of you know about these 3 layers. It's ectoderm, mesoderm, and endoderm. And that's how this formation of 3 germ layers happening. So it's our discussion right now. Now, it's a bilaminar embryonic disc, again, epiblast and hypoblast. Epiblast and hypoblast. And actually it's like connection between 2 cavities. It's amniotic cavity and yolk sac or exosomomic cavity. Okay. And now let's concentrate our attention only on these cavities. On the surface of this amniotic cavity starts formation the structure which is named as a primitive streak. Now it will be shown, yeah, primitive streak. You see. Okay. And actually, even by this, we define the caudal end and cranial end. Yeah, so cranial end, it's a future head. So this is cranial end. Caudal end is a future tail. As well, humans don't have tail. You understand? It's just anal side of the body. So, but this is head part. And from the caudal end or tail end of the embryo, so form this primitive streak. Primitive streak. It's just invagination of cells, and cells are differentiated here. So now, a little later, it will be shown better. This is and just for instance, this is oropharyngeal membrane. It's a very fine connection between hypoblast and epiblast. It's a very fine connection. So when narrow cells are present here, and future when this oropharyngeal membrane ruptures, it's an opening of our oral cavity. So from opposite side we have cloacal membrane. So now caudal end, cranial end, and now let's see the cross section of this primitive streak. Left and right. Yeah. This again oropharyngeal membrane, and this is primitive streak. It composed of primitive node, primitive pit in the middle of this, and primitive groove. Okay, what is happening here? So primitive node, inside primitive pit we have this primitive groove, and from the primitive groove, so cells towards the caudal end, so starts differentiated, yeah, and the cells are differentiating and produce a lot of proliferating, yeah, its name is proliferating, and a lot of cells are formed in a primitive streak. And these cells, they has after the process known as invagination, they produce cells and they settle on the surface of the hypoblast, and actually replacing this hypoblast. Again, hypoblast is replaced by epiblastic cells. So and the hypoblast here stops existing. So and now it forms a layer known as endoderm or definitive endoderm. Furtherly, next day, 16th day approximately, so these cells keep migrating between these two germ layers. It's a primitive ectoderm now, so but it keeps migrating in the middle between them and forming the third germ layer, which is named as mesoderm. Intraembryonic mesoderm. Don't confuse this intraembryonic mesoderm with extraembryonic mesoderm we see here, yeah, which form the connecting stalk and also chorionic cavity. So that's they are two absolutely different types of cells, and they have another epigenomic changes. They have absolutely other program, but histologically they look the same, but program which is activated in them is absolutely different. Okay, and first mesoderm. So when we have ectoderm, mesoderm, and endoderm. So and before this process, before the process of gastrulation, we had 2 layers, epiblast and hypoblast, and after the gastrulation we formed 3 germ layers: ectoderm, mesoderm, and endoderm. Okay, future of the ectoderm. In future, ectoderm is forming the epidermis of skin, so uppermost layer of the skin, and also nervous system. So this all the nervous system is ectodermal in origin. Also, I can say that oral cavities, so and tooth and teeth, yeah, so they are ectodermal in origin. And some glands, some part of thyroid gland actually is also ectodermal in origin. Also, mesoderm. Mesoderm it's in future forming these structures like muscles, bones, blood, um, stroma of different organs, all the submucosal layers, so which we're going to discuss in the next semester. And of course, endoderm. Endoderm is responsible only for one thing, so it's for digestive system and derivates of this digestive system. For example, liver is almost totally formed by endoderm. Okay. So, if I'm mistaken, that's it in this video. I'm gonna show you little other things. So, neurulation I won't show it to you, but I will explain you the gastrulation from different side of view. Okay, again, so same picture, amnion, amniotic cavity, so let's move it very rapidly. Epiblast, hypoblast, extraembryonic mesoderm present, and umbilical vesicle, also named as a yolk sac, or secondary yolk sac, yeah? Connecting stalk here. Again, so here we will see a little more details. We have cranial and caudal end, so and here will appear a primitive streak, and here we have oropharyngeal membrane and also cloacal membrane. So just to reminder, just a little reminder, a cloacal membrane it's formed from the word cloaca. Cloaca, so you know it's a common organ for the removal of feces and urine, and also used for the genital properties. For example, egg extraction goes through the cloaca in birds, for example, and reptiles also. And only in mammalians it's split into genitourinary system and also digestive system. Okay. Some question? No. Okay. And then primitive streak, as we discussed before. On the level of primitive streak, we have differentiation of cells, and it first of all, first process is known as invagination, and epiblastic cells from primitive streak invade the hypoblast and replace the hypoblastic cells and forming the endoderm, or definitive endoderm. And mesoderm is formed also from primitive streak, and here it's pointed out, so it's intraembryonic mesoderm, yeah, this mesoderm, and yeah, here I want to explain you the difference. So if ectoderm and endoderm, they're typical epithelial cells. You see, by arrangement of them you can see it, cells which are attached to each other. Between them we have very fine connections. As we discussed in our first lectures, they are desmosomes. So we are tight junctions, yeah, between cells, which making it very closely attached to each other. And similar we have in endoderm. We had it same in hypoblast, but here in ectoderm, in endoderm, it's also remains, so also very fine connection between cells. But here are formed so named mesenchymal cells. Mesenchymal cells. As mesenchymal means they have no connection to each other. So, and you already understand what is the blood cells, yeah, for example, erythrocytes. They are not bound to each other. Predominantly cells are bound to each other in our body, but we have a lot of cells which are mesodermal, so also not mesodermal, but mesenchymal in function, mesenchymal by its feature, and mesenchymal in derivation, and that's why, and they have no connection to each other. So, and this is and now embryo is composed of these 3 layers, but it's only in one a little part of the embryo. It's forming 3 layers. So if we remove the ectoderm, so now it's not epiblast, it's ectoderm. If we remove it out and imagine the site of mesoderm formation, you see mesoderm is formed only around the primitive streak, but the rest of embryo doesn't have this mesoderm. And then the task of mesoderm to be spread between ectoderm and endoderm. And along with the growth of embryo, so mesoderm growing a little faster to cover up all the embryo, and it covered everything up. So just want to point it out. It covers everything up besides the oropharyngeal membrane and cloacal membrane. Sorry, cloacal membrane. So oropharyngeal membrane, cloacal membrane remain intact. So because between them we have no mesoderm, no need of this mesoderm, because it's going to be ruptured to form oral cavity and future anal canal and genitourinary sinus. So that's why these parts are not covered with mesoderm, because mesoderm will form the increase the thickness of these membranes, and it will be challenging to perform it. Okay, and now we have a trilaminar disc. Finally, all the disc is trilaminar. And during the growth, you see what happened with the primitive streak. So primitive streak, so actually shrinking, yeah, shrinking, and embryo is very large. So actually, this primitive streak later will be totally dissolved, and remain no remnants. And only in pathological situations, these remnants will form the teratomas. Different types of teratomas are formed most commonly from primitive streak. What are teratomas? So you will discuss it in clinical subjects. Okay. Now, notochord formation. Yeah. So one moment I have to explain you. Have to show you here. So maybe you mentioned that from the primitive pit arised the special structure, notochord. Notochordal process. So this notochordal process is growing, and along with the mesoderm spreading, so it reaches the oropharyngeal membrane and remained only here. So how this process goes will be its next part of this video. So, but you see the consequence of it. It's not coincidence that as well we have notochord here. So around it we have a neural plate. So actually notochord is like endocrine organ now. So actually notochord producing special chemicals, hormone-like chemicals, so very large hormone-like chemicals, protein-like, so which change in the genetic program of the cells. They predispose the cells to form something else beside these cells. And you see a little darker blue area here. It's known as a neural plate, and as name implies, so it's a future nervous system. Yeah. So that's that you have to keep in mind. Okay, and now finally let's talk about notochordal process. So how notochord formation takes place. So now you see we have sagittal view, cross-sectional view. So you see this is primitive streak from this side, and this is primitive pit. And as well you see here we don't have mesoderm. Here between them we don't have mesoderm, and the process of spreading of this mesoderm will also evolve the notochord, and started from notochordal plate. Take a look. So in a cross-sectional view, so notochordal process just in the beginning of its formation. Let's look closer. So and here so from the primitive pit, again epiblastic cells of primitive pit, they start growing towards the oropharyngeal membrane, which is present on the opposite side, and along with the spreading of mesoderm, so notochord, like a fine tube, so it enters into the following the growth. And you see inside this notochord, so we have a connection, yeah, between notochordal canal, so notochordal canal here, with the amniotic cavity. Upside we have an amniotic cavity, so just a reminder, and this notochordal process is still present. Okay, and mesoderm is growing along. Okay, but later in one day we have one strange case. We don't actually totally understand the reason of this. So we have different suggestions, but we have a one day moment when notochord fuses with endoderm. Again, notochord which formed here fuses with endoderm, and which is opening this canal. It's also named as a neuroenteric canal, so now it will be pronounced. And actually primitive pit, it is a connection between yolk sac and amniotic cavity. So notochord is fused with endoderm, and in here forms a neuroenteric canal. Again, not neural canal, not enteric canal, a neuroenteric canal. It's a temporal structure in embryo, so which will be closed in one day. So how it closes, let's see it now. So then notochord fuses back, infolding of notochord happening, so and reinforcement of the endoderm. So endoderm is closed, and now we have a notochord which were raised from ectoderm, which were fused with endoderm, and notochord is present in between. And also might be mentioned that notochord already specialized the cell, differentiated the cells of ectoderm. They form in the neural groove. And actually this neural groove, of course, if it's groove, so nearby we have a fold. Yeah, so that's a neural groove and neural fold, which will take place in a process known as neurulation. It's a point of our next class discussion, next lecture discussion. Again, you see notochord, which is growing here, it were predisposing the formation of neural plate, and now gastrulation is finished. And also along with it we have a formation of allantois. So allantois is a little outpoaching of the endoderm toward the connecting stalk or umbilical cord. And this allantois, it will play a very important role in formation of urinary bladder and genital organs, so outer parts of genital organs. Okay, that's it. Okay, thank you for attention. So if you have any questions, you can ask me now. No one write in the chat. So any questions? If we have no questions, so let me check your attendance.
Hello, sir.
Yep.
I am Muhammad Abdullah. I am a new student in Salimba course. Please give me your introduction.
Give you what? Sorry. Introduction? So link to the lectures, I guess. Yes, you meant link to the lecture. So please, for link to the lecture, I send it to the group in WhatsApp. So ask your group mates; they will send it again. So I have a playlist, so where I add these lectures, so you can see it online. And also I sent a PPT of those lectures where I have PPT. And for this lecture I don't have PPT, so because I explain everything on the video. Okay. Any more questions? Okay. Thanks. See you next time. Goodbye.